Welcome back. Let's look at the discriminant. So when we solve a quadratic equation, we can have three types of solutions. Real numbers and have rational solutions. That means there's no radicals. We could have real numbers and irrational solutions. That means we have radicals. Or we could have complex numbers. There's I, and we have imaginary numbers. Because it distinguishes among the three types of solutions, b squared minus 4ac is called the discriminant. It's going to tell us what kind of solutions do we have. Do we have real numbers and they're rational? Do we have real numbers but they're irrational? Do we have complex numbers? So the discriminant will tell us that. The discriminant is the value under the radical for the quadratic formula. This determines the nature of your solutions. It doesn't tell you what your solutions are, just what kind. And you have this in your notes and even all of my little handwriting. All right, so first of all, you can only use if your equation is in standard form. So if it's not in standard form, put it in standard form. All right, and so now let's look at three types of discriminants. Greater than 0, equal to 0, less than 0. And let's look at the number of real roots we have. All right. So let's take a look. So if our discriminant is greater than 0, so b squared minus 4ac, that's greater than 0, we have two real roots. There's two different things it could be. It could be we have rational solution or an irrational solution. If you have a perfect square, right? So when you take b squared minus 4a squared, let's try that again. B squared minus 4 times a times c, whatever that number is, and we're going to do some problems on the next page. If that number is a perfect square, like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc., or 0, but 0 is going to be something different. If you have a perfect square, then you have rational solutions and you can factor. So go ahead and use factor by grouping, right? So if it's a perfect square, you can use factor by grouping. You're going to have, I believe yes, it has that information. You'll need to know it has two x-intercepts if you have two real roots. If your b squared minus 4ac, if that is not a perfect square, anything but 1, 4, 9, 16, 25, 36, 49, etc., then that's an irrational number. You need to use completing the square or quadratic formula, right? One of the two. So, like I said, if b squared minus 4ac is greater than 0, you have two real roots. That is two x-intercepts, right? You have two x-intercepts. If b squared minus 4ac is equal to 0, oh, by the way, another word for x-intercept, sometimes are also called zeros. Right? Sometimes they're called zeros too. All right, so if b squared minus 4ac, if that equals 0, you have one real root. That means you have one x-intercept and it's repeated. It's going to be factorable if it is a perfect, it is going to be factorable, because it is a perfect square. All right, because 0 is a perfect square. I said that in the last one, but I said 0 is special because there's only one x-intercept and it's repeated and you will be able to factor. If b squared minus 4ac is less than 0, you have no real roots, won't cross the x-axis, you have no x-intercepts, but you do have two imaginary roots, and you do have to use completing the square quadratic formula. Okay? So if your discriminant is a perfect square or 0, you can solve by factor by grouping. If your discriminant is greater than 0 and not a perfect square, or less than 0, you have to use completing the square quadratic formula. All right, so let's take a look at a few examples. All right, so here, and so I'm going to solve these, and then I have some that are in your notes as well. All right, so here we have x squared plus 3x minus 1 is equal to 0. Let's find our discriminant. All right, so we take, and let's write down a, b, and c. A is equal to 1, b is equal to 3, c is equal to -1. So I have 3 squared minus 4 times 1 times negative 1. That's going to be 9 plus 4, right, because I've got two negatives there, so that's going to be positive. That's 13. So 13 is greater than 0, but not a perfect square. All right, so I'd have to use completing the square, or quadratic formula to solve. All right, I could not factor. All right, here we can see it's greater than 0, so we do have two real solutions. Right? They are going to have radicals involved. I'll solve it real quick. Right? So I'll just do completing the square because it's probably good for us to. Maybe I'll alternate. All right? So this one I'll do completing the square one. Next one I'll do quadratic formula. Actually, I should see. Does the next one have an even? Yeah, I'm definitely doing completing the square on this one, quadratic formula on the third one. All right, so completing the square, we'd have x squared plus 3x minus 1 equals 0. We would add 1 to both sides. So x squared plus 3x is equal to 1. I don't have a whole lot of space, so I'm going to just leave a space there so I can add my b divided by 2 squared. 3 divided by 2 squared plus 3 divided by 2 squared. Perfectly fine to leave a space and then add it in. All right, so this is x squared plus, oops, what happened to my x again? 3x plus, this is going to be, so 3 squared is 9, 2 squared is 4. That's equal to 1 plus 9 fourths. All right, so over here I've got x squared plus 3x plus 9, what happened to my 4? There we go, fourths. And this would be 4 fourths plus 9 fourths. We can factor now. This would be x plus half of b, so that's going to be 3 halves. And do not make that a decimal ever when you're doing completing the square. Just makes a mess. Squared, right, because it'd be x plus 3 halves times itself, is equal to 13 fourths. All right, so now we'll take a square root of both sides, which I'm going to do over here. So I have the square root, my shadow was blocking me, plus 3 halves squared is equal to plus or minus, I'll split that fraction, and so it's 13, square root of 13 divided by square root of 4. Square and square root cancel, that's x plus 3 halves equals plus or minus, I can't simplify the square root of 13, but the square root of 4 is 2. And now all I have to do is add 3 halves, or subtract 3 halves from both sides. So x is equal to negative 3 halves plus or minus the square root of 13 divided by 2. And you know, I had lots of space to put this up here. There. Oh, now I've got a random line. I'll get rid of that later. All right, so my two solutions are negative 3 halves plus square root of 13 divided by 2, and negative 3 halves minus square root of 13 divided by 2. So this point here, that's going to have to be the negative, this would be the negative 3 halves minus, because it's smaller, square root of 13 divided by 2. And then this point over here, that would have been the x, oh, excuse me, negative 3 halves, negative 3 halves, minus the square root of 13 divided by 2. So here we have two solutions. They're real, but they are irrational. Right? Right, so a little practice with completing the square. Let's look at the next one. So this is just a little extra stuff that's not in your notes. So this one here, let's find our discriminant. Right, so our A is 1, B is negative 4, C is positive 4. So we have negative 4 squared minus 4 times 1 times 4. And that would give us 16 minus 16. That's 0. All right, so that means we're going to have only one real solution, and this you could factor. Right, so it's because B, or our discriminant is equal to 0. Right, so we could use factor, and we'll do that. All right, so x squared minus 4x plus 4 equals 0. 1 times 4 is 4. Multiplies to give us 4, adds to give us negative 4. That's going to be negative 2 and negative 2. So we have x squared minus 2x plus negative 2x plus 4 equals 0. First two are a group, second two are a group. Greatest common factor is an x. Factor on an x, we have an x minus 2. Greatest common factor for negative 2 and 4 is going to be a negative 2 because we want an x minus 2. Negative 2x divided by negative 2 is an x. 4 divided by negative 2 is negative 2. That repeating factor can be factored out, leaving the leftovers. You see, we have the same solution. We have x minus 2 equals 0. Well, x minus 2 equal to 0, x is going to equal 2 twice. Right, so this is a repeated solution. Only appears once, or excuse me, we only have one x-intercept because we have the same solution twice. We'll talk about this more when we get to graphing a little later on. All right, so here, let's take b squared minus 4ac. So a is negative 3, b is equal to 20, and c is equal to negative 34. I'm actually going to divide everything. I can do that so long as I do it to everybody by negative 1, because I'd prefer a not to be negative. So negative 1, negative 1, negative 1, negative 1. That's going to make this 3x squared, so now that's positive. That's going to make our b here negative 20x. That's going to make our c a positive 34. And it's still 0. All right, so dividing everything by the same number does not change anything in the equation. But it will make it easier for me to solve it in a moment. So b squared minus 4ac, I have 20 squared, negative 20 squared, minus 4 times 3 times 34. That was a plus there. 34. So that's going to be 400 minus whatever 12 times 34 is. All right, well, 34 times, I don't have a calculator right next to me. 34 times 10, that's 340. And 34 times 2, since I'm trying to divide it by 12, that's going to be 68. So that's going to be 408. So that's just a little trick there. You can break it up when you're multiplying a number that's maybe a little too hard to do in your head. You can break that, so I can break 12 into 10 and a 2. Right, so 10 34s plus 2 more 34s gives me 12 34s. All right, so 400 minus 408, that's going to be a negative 8. And negative 8 is indeed less than 0. So we have to use either, now we have 2 complex solutions. And actually I have it up there, so I won't write it again. So we do have to use either completing the square, or quadratic formula. I used completing the square on the last one, or this one 2 before it. So it's quadratic formula. All right, and so remember, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac, all divided by 2 times a. Right? So my negative b, that's going to be, so I'm using this equation. And you would too. You don't want a to be negative. And then you got to simplify later. So b here is going to be a negative 20 or 20 plus or minus. I know what b squared minus 4ac is. We just calculated it out a moment ago. It's negative 8. No reason that I should plug it all back in again to just to get the same thing I got 2 minutes ago, which was negative 8 divided by 2 times 3. Hey, one to simplify finally. X is equal to, so we got 20 plus or minus the square root of negative 8 divided by 6. And do I have enough room to simplify? Let's come over here. Follow the arrow. All right, so 8, that's 4 times 2, or 2 times 2. You know what, let's just make the board longer, huh? 2 times 2, 1, 2 comes out, 1, 2 goes away, 1, 2 is left under the radical. But don't forget it's negative, so it's going to be like a negative 8 times a negative 1. Negative 1, of course, is equal to I. So we're going to have 20 plus or minus 2I square roots of 2, all divided by 6, and everybody's divisible by 2. All right, so you're divisible by 2, so that'd be a 1, or just an 1I, or an I. 20 divided by 2, you're at 10. 6 divided by 2, you're at 3. So now my answer is, oh, this is supposed to be x is equal to 10 plus or minus I square roots of 2 divided by 3. Finally, one we had to simplify. All right, so since there's an I, notice no x-intercept. All right, so you'll know when we get a complex solution, don't be expecting to have an x-intercept. There won't be. All right, so now let's do the 4 that were in your notes. So here we did a little review. Let's do a little more review without the picture. All right, so, and here we have all the words. All right, so we have 3x squared plus 2x plus 4. All right, and so discriminant is negative. Let's find the discriminant. Discriminant is, so let's see, A is 3, B is 2, C is 4. So this would be, so remember, discriminant is b squared minus 4ac. I'm not going to write that every single time. I'll just put it at the top of the page. So I have 2 squared minus 4 times 3 times 4. So that's going to be 4 minus, there's only one negative there, so that's going to be 12 times 4, or 48, and that is a negative 44. All right? So I have to use either completing the square or a quadratic formula because I have a negative discriminant. Right, if your discriminant is negative, but that's in your notes, if your discriminant's negative, all right, you're not going to be able to factor it. I'm going to use quadratic formula on this one. I'll do completing the square on the next one. All right, so we have, I'm going to use quadratic formula. So it's going to be x is equal to negative b plus or minus b squared minus 4ac divided by 2a. In this case, I mean, unless you want to check yourself, you know, I feel pretty confident. I'm looking up there. Okay, 2 squared, that's definitely 4. There's only one negative, so I'm subtracting. And then 4 times 3 times 4, definitely 48. And 4 minus 48, definitely negative 44. So I feel okay writing in negative 2 plus or minus negative 44. Right? That's what b squared minus 4ac is going to be. Divided by 2 times 3. And we're going to get to simplify again. Yay, I chose the right one to do quadratic formula with. X is equal to negative 2 plus or minus, so 44, negative 44. You can think of that as 44 times negative 1. 44 is 4 times 11. 4 is 2 times 2. 1, 2 comes out. 1, 2 goes away. Of course, the square root of negative 1 is I. All right, so we're going to have a negative 2 plus or minus 2i square roots of 11 divided by 6. And everybody is divisible by 2. Remember, it's everybody or nobody. So here we'll divide everybody by 2. All right, so now you're negative 1. You're just going to be 1i, and you're going to be 3. So final answer, x is equal to negative 1 plus or minus I square roots of 11 divided by 3. Right? Make sure you simplify correctly. And we're done with this one. Right? Well, when I told you you had oodles of space on the next page, I guess I was lying, because unless you write really small, you might need to use some of that space at the bottom there. Of course, we got the space under the discriminant there on the side of your notes. All right, let's look at this one. All right, so discriminant is, all right, so we have, remember it's b squared minus 4ac. All right, so we're going to have our a is 1, our b is 7, our c is 3. All right, so that's going to be 7 squared minus 4 times 1 times 3. So it's going to be 49 minus 12, which is 37. It's positive, so we're going to have two real solutions, but it's not a perfect square. So we're going to have radicals. We have to use completing the square quadratic formula. This time, let's use completing the square. Okay? You don't have to underline it, but we're going to use completing the square. Our first step for completing the square, since a is 1, is to subtract 3 from both sides. Right, so we have x squared plus 7x is equal to negative 3. I'm going to leave a space there so I can just add in b divided by 2 squared. Buzz, 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 divided by 2 squared. So 7 divided by 2 squared, 7 divided by 2 squared. So x squared plus 7x plus 49 fourths, just square both of those, is equal to negative 3 plus 49 fourths. By the way, if you know you're going to, if you have a fraction, right away you could, change that negative 3. I'll just do it on the next step. X squared plus 7x plus 49 fourths is equal to, so it has to have a denominator of 4, but it still has to be equal to 3, or negative 3, so that means negative 12 is going to be the numerator. Right, so on the left-hand side, I can factor x. We've got a plus, b is positive, and then half of b is just 7 divided by 2. No decimals. And then we have another x plus 7 halves, or just make it a squared. Negative 12 fourths plus 49 fourths is going to be 37 fourths. All right, and so now take square root, plus or minus, split that. So 37 and square root of 4. All right, so square and square root cancel. I have x plus 7 halves. And then plus or minus, 37 is a prime number, but the square root of 4 is 2. And all I have to do is subtract 7 halves from both sides. I'm just going to write it. We know it's going to be, the sign's going to be reversed. Negative 7 halves plus or minus the square root of 37 halves. If you wanted to be one fraction, since they both have 2 in their denominator, you could just write that as negative 7 plus or minus square root of 37 all over 1, 2. Right, so you could also write it if you wanted. This is perfectly fine. X is equal to negative 7 plus the square root of, plus or minus the square root of 37, all divided by 2. Both of those are correct. We're both the same thing. Oh man, this one is a little bit longer than I planned, but we're almost done. All right, so let's find our discriminant here, all right? So again, I'm just going to divide everything by, it's not negative 3. That wouldn't be so good. Negative 1. All right, so now I have 3x squared minus 5x minus 2 equals 0. All right, exact same equation. All right, I just divided, for solving, I just want to divide by the negative to make it a little easier to solve. All right, but, well, it's not the exact same equation. If we were to graph it, we'd have a negative 3x squared, and positive 3x squared would make very different graphs. However, for solving, it will not matter that I divided everything by negative 1. Nor will it matter for my discriminant. All right, so I'll still have the same thing. All right, so we have, because, by the way, so the a is not negative anymore, but now the c is. That's why it won't matter. So A is 3, B is -5, and C is -2. So B squared minus 4AC, we have -5 squared minus 4 times 3 times -2. So that gives us 25. That's going to be a plus. And then we have 12 times 2, that's 24. And that's 49. And 49 is a perfect square. And it's positive. If you have a negative perfect square, you still can't factor. You'll have to use completing the square quadratic formula. Actually, if you have a negative square, use completing the square. All right. If this was -49, use completing the square. You're going to have something really, you can have something nice and easy to deal with. All right, so we're going to factor. And I've already divided everything by -1. I factored out a -1 to make it easier for us. So A times C, that would be 3 times -2. That's equal to -6. So we need two numbers that multiply to give us -6, but add to give us our B term of -5. Well, that's going to have to be a -6 and a 1. All right, those will multiply to -6 and they'll add to -5. So we're going to keep that 3x squared minus 6x, so we're replacing the -5x, plus x, and we keep the -2, equal to 0. First to our group. Second to our group, don't forget the plus in between. 3x squared and -6x, greatest common factor is a 3x. 3x squared divided by 3x is x. -6x divided by 3x is a -2. Look at that, it matches x minus 2 and x minus 2. That's good because their only common factor is a 1. X minus 2. So we have the repeating x minus 2 to factor out, which would leave us with the leftovers. We just set them equal to 0. X minus 2 is equal to 0. X is 2. 3x plus 1 is equal to 0. And we'd have 3x is equal to -1. X is equal to -1/3. One of the factors is negative. It should have a positive solution. It does. The other factor is positive. It should have a negative solution. It does. No sign errors there. And we're done with this one. Okay. Looks like we're on the last problem in your notes, which is my last problem. All right, so let's find our discriminant. So B squared minus 4AC. A is 1. B is 2. C is 1. So I've got 2 squared minus 4 times 1 times 1. Well, that's 4 minus 4, and that's 0, which means one real rational solution. It's a perfect square. Use factoring to solve. I'm going to do factor by grouping, and then I'm just going to remind you of the factoring used for completing the square. And you can use that here, but I'll just use factor by grouping right now. So A times C is going to be 1 times 1, which is 1. Two numbers that multiply to give us 1, add to give us 2, of course, is 1 and 1. So x squared plus x plus 1 equals 0. First to our group, second to our group, don't forget the plus. Greatest common factor for x squared and x, of course, it's x. Divide x squared plus x by x, and you get x plus 1. Greatest common factor for x plus 1, of course, is 1. X plus 1. So we have the repeating x plus 1 we can factor out, and the leftovers are also x plus 1. We could also write this as x plus 1 squared. Right? Doesn't really make any difference, though, because we were solving. All right, so x plus 1 is equal to 0. Our one and only solution is -1. So remember, if it's a perfect square, it'll follow the same pattern as we used to factor when we were doing completing the square, right? X plus or minus b squared, right? Or you can think of it as x plus or minus b times x plus or minus, oops, there we go, parentheses, x plus or minus b. Oops, excuse me. I wrote b. Oh, shame on me. X plus or minus b divided by 2. Buzz, buzz, buzz divided by 2. Or x plus or minus b divided by 2. X plus or minus b divided by 2. Sometimes my hand, my mouth are working faster than my head. All right, but I knew what I wanted to say, which was b divided by 2. Let's see if that works out in this case. All right, so here we have x squared plus 2x plus 1. All right, what's half of b? What's half of 2? Half of 2 is 1. We got x plus half of 2, 1, times x plus half of b, or half of 2, 1. Right? So notice, if you have a perfect square and you recognize, hey, that's a perfect square, or you do the discriminant and you get 0, you can use the same factoring that we used when we were doing completing the square. Right? You can, do that a little easier than factor by grouping, because this one's so easy. Whoa, 30 minutes. That's longer than I usually like to go on for podcasts. Well, this is the last thing I'm going to say, and that's the comparison of each method of solving quadratic equations. All right, so just comparing, there are good things when you can use them. You can write this down, but you don't have to write this down. Right? So factor by grouping, or greatest common factor. Remember, we had 2. All right, we could use both of those. That was the first 2 lessons. First few lessons actually. One benefit is you don't have any radicals. That's because you get rational numbers. It's an easy method, and the greatest common factor is used when there is no C term. Now, if you're someone who forgets that, maybe write that down. Maybe actually this might be good for you to write down now I'm saying it, but you don't have to. But I'll be kind of noticing if you write this down, and I might be favorable to you if you write it down. Square roots used when there's no b method, or if it's easy to have something squared equals a constant. Completing the square, you get factorable numbers, answer when no rational solution, and it can be used all of the time. Also, quadratic formula, answer when there's no rational solution. Easy to see mistakes, but remember to check. Right? You only see the mistakes if you check. You got 2 negatives, that's plus. Right? Got an odd number of negatives, it's minus. And it does come straight from the equation, but really watch that simplifying. That's where I'm seeing the errors. Right, well, I hope you enjoyed learning all about solving quadratic equations, because I'm going to say bye for now.